In this tutorial, I'm going to go over a more in-depth look of how we add and subtract polynomials with the use of algebra tiles. Let's first take a look at this example. We are doing an addition problem here. We're adding two polynomials. So what this means is this addition symbol, we are going to be adding the entire parentheses. So everything inside here, both the 4x and the 2, need to be added because we're adding the entire parentheses. So I'm going to rewrite this problem without parentheses with this idea in mind. So I keep the 2x plus 3, and then I'm going to add both terms inside the next parentheses. So I'm adding this positive 4x, and then I'm adding again. Now the next one I have is a positive 2, so I'm adding a positive 2. Okay, so I've rewritten it. Now what we can do is we can represent this problem using algebra tiles. How an algebra tile works is I'm basically just expanding this out, this problem here, to break it down step by step so I can see what it really means. So first of all, we have 2x here. 2x, that means we have two x's. So I'm going to make two little tiles that have an x in them. Next, we have a positive 3. Notice how to determine if it's positive or negative, I looked at the sign that comes before the number. So here's the 3, I look before it. It's a plus sign, meaning that this 3 is positive. At the beginning, the 2x, looking before it, there's no sign, which means it's also positive. I'm noticing no sign or plus signs for all of these, so each one of these numbers in this problem is going to be positive. Just a side note on how I decide if it's positive or negative. Okay, so anyway, we have a positive 3, which means that I have 3 ones. So I'm going to make 3 tiles that have a 1 in them because 1 and 1 and 1 makes 3. Next up, we have a positive 4x, meaning I have 4 positive x's. So I can make 4 tiles that have a positive x on the inside. And then lastly, we have a positive 2. So I'm going to make 2 tiles that have a positive 1 on the inside. So now I've expanded each one of these terms out using tiles, and I'm going to combine the tiles that are in common. So we have 2 tiles here that have a positive x, and 4 tiles that also have a positive x. So I can see that all together here I have 6 positive x's, and then we have 3 ones that are positive and 2 ones that are positive for a total of 5 positive ones, or just a plus 5. So that is how I combine all of these like terms together here using algebra tiles. Added up, this equals 6x plus 5. I'm adding the terms that are in common to make one simplified form of this expression. Let's now look at another example of an addition problem of polynomials. So again, I'm adding, meaning that everything inside this set of parentheses here is going to be added. So I'm going to rewrite this with this idea in mind. So I'm going to be adding positive 4x squared, adding positive 4x squared, adding positive 2x, so adding positive 2x, and then lastly adding positive 1. So I'm adding and a positive 1. So I've expanded it out, and now I'm going to write down the tiles for each one of these. So first of all, we have 3x squared, meaning we have 3 x squareds. So I can make 3 tiles that have an x squared. Okay, next up we have a positive 2x, meaning we have 2 positive x's. So I'm going to make 2 tiles that have a positive x. Next then we have a positive 4x squared. So I have 4x squareds. So I'm going to make 4 tiles that have an x squared, since I have 4 of them. Next, we have a positive 2x. So I'm going to make 2 tiles that have a positive x. And then lastly, we have a positive 1. So there's no x's here, so I'm just going to make a tile for the 1. Now let's combine whatever is in common. So here we have 3x squareds. I'm going to look for other x squareds. It is really important that it has to be an x squared. If it's just an x, we cannot combine it. That is something different. It needs to be an x squared. So I have 3x squareds here. I also see that I have 4x squareds here. So this is what I can combine together. Altogether, we have 3 and 4 makes 7x squareds. Next, we have 2 x's by themselves. There's something different. We cannot combine them with the x squareds. And I have 2 more x's by themselves. So altogether, 2 and 2, we have 4 x's by themselves. And then lastly, we just have that one single 1 tile. So that makes a total of just 1. And this is the final simplified version after adding the polynomials. Let's look now at another example. So again, we're adding these 2 polynomials, but this time one of the polynomials has some subtraction in it. So that's going to slightly change how we do things, but the general idea is still the same. We're adding these 2 parentheses together. So this addition will apply to everything inside the parentheses. So I'm going to first rewrite my problem, 3x squared plus 4x. Then I'm going to be adding this first term here of x squared. So I'm adding x squared. Then again I'm adding because everything inside here is being added. So next I'm adding this negative 5x. And since it's a minus 5x, I need to put in that negative sign because the symbol that comes before it, the sign, it's part of the number. It's not just a 5, it's a negative 5. So it's really important that I put this negative symbol in there. Positive numbers don't need a symbol. I don't need the positive to make this x squared positive. But if it's a negative sign, it needs that negative symbol. This is uber important. Okay, so I added that one. Now adding my last one. So I'm adding the last term inside the parentheses is negative 2. So I'm adding negative 2. So now that I've rewritten it, let's make the tiles. So first we have 3x squared, meaning I have 3x squareds. So I'm going to write 3 tiles that have an x squared. Next up, we have positive 4x. So I'm going to make 4 tiles that have a positive x. Next up, we have positive x squared. There's no number here. It's like an invisible 1. We just have 1x squared. So I'm going to make 1 tile that has an x squared. Next up, we have plus negative 5x. So in this case, my x's, I have 5 negative x's. So I'm going to again make 5 tiles, but this time the x's are negative, and I should have 5 of these because I have 5 negative x's to make negative 5x. And then lastly, we have plus negative 2. So I have a negative 2 here. So my 1's should be negative, and I have 2 of them to make the 2. I have 2 negatives. Now let's combine what's in common. So first, the x squareds. We have 3x squareds and another x squared for a total of 4 x squared tiles. Next we have, let's just do the x's by themselves. So I have 4 x's, 4 x tiles here. And here, these are negative x's, but because the x doesn't have an exponent, it's just an x, I can combine it with these other x's over here. So I can combine these together. So I have 4 positive x's and I have 5 negative x's. So I'm adding positive x's and negative x's. When I add positive and negative, every pair cancels out. So one pair of a positive x and a negative x cancel. Positive x and negative x cancel. Positive x, negative x cancel. Positive x, negative x cancel. So in the end, I'm left with just this one negative x. So I have a negative 1x. There's just only one negative x left. And then lastly, the only thing that I haven't included yet is these 2 negatives. So I have negative 2 wholes. And this is how we would combine this addition problem to be the most simplified answer. Now let's take a look at some subtraction problems. So subtraction of polynomials is very similar to addition of polynomials. The difference now is that we are obviously subtracting them. So this is super important that this entire parentheses is being subtracted. It doesn't just say minus 2x, it says minus the parentheses. Everything inside the parentheses is being subtracted. So it's really important that we think of this as we're rewriting it. So I'm going to rewrite this problem. So the first part stays the same, but now I'm subtracting it. So I'm doing minus 2x minus a positive 2x, and then minus positive 1. So I also need to do minus positive 1. Notice how this positive 1 is also being subtracted. You could put in a little positive there to make it a positive 1, but with positive numbers, we don't need the sign. It's only required if you have a negative number that you absolutely need the minus. But just to make it a little less confusing, having less symbols, with the positives, I'm just going to leave this little positive out. I have minus positive 1, minus positive 1. Now that we have it expanded out with no parentheses, I'm going to use my algebra tiles to help me see what each one of these would be. First, we have a positive 4x, so I'm going to have 4 positive x tiles. Next, we have positive 3, so I'm going to have 3 positive 1 tiles. Next, we have negative 2x. Notice how I was sure to think about the minus sign that comes before. It's not just 2x, it's minus 2x. So I'm going to have 2 tiles again, but this time they are going to be negative x's, since I have 2 negative x's. And then lastly, I have negative 1. So I'm going to have 1 tile, and this time it's going to be a negative 1. Since I have a minus sign here, it makes this negative. Then we're going to combine whatever is in common. So I have a couple groups here that have just an x, so these are the ones that I can combine. I have 4 positive x's and 2 negative x's. So remember, positives and negatives cancel. So I'm going to cancel every group of positive x, negative x, positive x, negative x. All right, there's no more to cancel. I'm left with these 2 positive x's. So I have a positive 2x. Now let's combine the single 1 tiles. We have 3 positive 1s and 1 negative 1. So a group of positive 1 and negative 1 cancels. And I'm left here with just 2 positive 1s, so a positive 2. And this is the simplified version of this subtraction problem. Let's take a look now at another example. So again, we are subtracting, which means that we're subtracting parentheses. So everything inside this parentheses is going to be subtracted. Let's first start by rewriting this. 4x squared plus 3x Then I'm going to subtract everything. So minus a positive x squared, and then again minus, and then the other thing we have is a positive 5x. So minus positive 5x. Now that I've rewritten it, I'm going to make my algebra tiles. First, 4x squared. This means I have 4x squareds. So I'm going to make 4 tiles, and all of them are x squareds. And they are positive x squared since my 4 is positive, since there is not a negative sign in front of it. Next we have positive 3x, so I'm going to make 3 tiles, and all of them will have a positive x. Next we have minus x squared. In this case, there's not a number here, but it's like we have an invisible 1. So I'm going to have 1 tile, and it's going to be a minus x squared because we have a negative x squared, so it's important that this tile is negative. Lastly, we have a minus 5x, so again I'm going to make 5 tiles, and this time they are going to be minus x because my 5 x's that I have are negative. So I have 5 negative x's. Now we're going to combine what is in common. So first let's take a look at the x squareds. We can combine those together. We have 4 positive x squareds and 1 negative x squared. Positive and negative cancel, so I can cancel one of my tiles from each group, and I'm left with 3 positive x squareds. So this is 3x squared, since I have 3 positive x squareds. And then for the x's by themselves with no exponent, we have 3 positive x's and 5 negative x's. Every group of positive and negative, each group of 2, cancels, so a positive and negative cancel, positive and negative cancel, positive and negative cancel. So I'm left with just 2 negative x's, so I have a negative 2x. And this is the answer to this subtraction problem. Let's take a look at another subtraction problem now. So again, I'm going to repeat this again because it's so important and it's a really common mistake and I don't want you to make it. This subtraction, it's for everything inside the parentheses. So we're going to be doing minus this, and minus this when we rewrite it. So the first parentheses will stay the same. Then we're going to subtract each term inside the second parentheses. So minus, and then our first term is positive 4x squared. Then again, minus. And our next term is negative 2x. Notice how we are doing minus, again, because everything inside is being subtracted, so minus. And then I looked at this complete number. It's not just a 2x, it's a minus 2x. So I am subtracting a minus 2x. I'm subtracting a minus 2x. It's very important that you keep both of these negative symbols. And then again, for our last term, we are again subtracting. So I will put minus, and then our last term is minus 3, a negative 3. Since it's a negative, we need that negative symbol. It's minus a negative 3, minus negative 3. Okay, so now that we've expanded it out, I'm noticing some places where I have 2 symbols together. So I'm going to try to make this a little bit easier for me to solve by combining it into 1. So when I have minus a negative, I remember that minus negative, I can change these both to addition and make it plus positive. Thinking of this as plus positive is going to be much easier for me to solve than thinking of it as a minus negative. So I'm going to rewrite this, but I'm going to make these 2 parts here where I have minus negative, I'm going to make them plus a positive because that will be easier for me to think of. So first we have our 5x squared plus 3x minus 4x squared. Now when I have minus negative 2x, I'm going to make it plus positive 2x. Notice how when it's positive, I don't need that additional symbol in there. It's only when it's negative. So this here means plus positive 2x. Then again, minus negative 3, I'm going to make it plus positive 3, like that. Now that I have it simplified, everything just has one sign in front of it. Now I'm going to make my tiles. So first we have 5x squared. So I have 5 positive x squareds. So I'm going to make 5 tiles that have a positive x squared. Next we have a positive 3x. So I'm going to have 3 tiles that have a positive x. Then we have a negative 4x squared. So I'm going to have 4 tiles, but this time there will be a negative x squared in each of them. Then next I have a plus 2x, a positive 2x. So that means I can have 2 tiles with a positive x. And then lastly we have plus 3 or positive 3. So I'm going to have 3 tiles, all with a positive 1. Next we can combine what we have in common. So I'm going to start off with my x squared tiles. I have 5 x squared tiles here, 5 positive x squareds. And here I have 4 negative x squared tiles. So to combine these together, positive and negative cancel. I'm left with just 1 positive x squared. I have 1 positive x squared. Now let's combine just the x's alone. We have 3 positive x's and 2 positive x's. In this case, we don't have positive and negative, so they don't cancel. We'll just add up how many total we have. 3 positives and 2 positives. Altogether, we have 3 and 2 makes 5 positive x's. And then lastly, we have 3 positive 1's. So I have positive 3. And here is the answer to this subtraction problem. Now I have 2 problems that I think it would be a good idea for you to try. Try them out, check to make sure that you understand how to do these. So in a second, pause the video, solve this on your own paper, and then when you have answers for both of these, you can play the video again to check your work. So go ahead and pause the video now. Here are the final answers that you should have gotten. You can take a look at my drawings of the algebra tiles and compare them to yours. Hopefully you got the same thing as me. If not, compare and see maybe what did you do that I did differently. A couple things I wanted to highlight is that up here on the addition problem, we added everything inside the parentheses. And since we had a negative 1 here, it was really important when I added it, I made this be a negative 1, which then cancels to make only 3 positive 1's left. Another thing I wanted to highlight is on the subtraction, I subtracted everything. And so I did minus a positive 2x and minus a negative 5x. Since it's negative, I need to add in that extra symbol there. Then I noticed that in this place here, I had 2 symbols, so I wanted to combine them together to just make 1. I know that minus minus is the same as plus, so this minus negative 5x becomes plus positive 5x. And then I had the drawings to go with it, canceled positives and negatives, added any things that were the same sign, and that is how I got my answers.